the University Rover Challenge. It's an annual international competition. So far there's been teams from Poland, Canada, and the United States, so it is reasonably international. It's held in Utah every summer. The MDRS missions, where you're there for 2 weeks, they only happen during the winter because it is very hot in the summer. And so in the summer, you're only there for a couple of days to do the Rover Challenge, and they shut down the actual facility to do repairs and construction and keep the upkeep that needs to be done. So for the first 3 years, there was only one Canadian team, and that was York University. So we figured we'd join them and try to compete. The goal is to make a wireless rover off the grid. It has to be independently powered, batteries or some other mechanism for power, and completely wirelessly controlled. You have to send the video feeds back. It's not autonomous. That's an important distinction, because you're reading the telemetry back and looking at the video feeds to drive around. The idea for this competition isn't that you're sending a rover ahead of time. It's that you're going to Mars and there's a rover with you, and the rover can do some of the dangerous tasks or some of the things that a human wouldn't want to go outside to do. There are 4 events that we have to participate in. I'll discuss each of those. And yeah, just the idea that Mars explorers need rovers. When you're out there, there's lots of things that just might be risky for humans to do. So who we are, interdisciplinary. And that means just that we had people from a science background, an engineering background. We had some people in strange degrees like urban planning that wanted to help out one time. So there's lots of different people coming together. About 70 people have helped since 2008. And so organizationally, we had some help from the robotics team and the Waterloo Space Society. The Space Society has some cool space knowledge, and the robotics team has some of the knowledge to actually build mechanized systems. So what it was, this is a schematic of our rover here. You can see 6 tires, and that's kind of neat because it can steer on the spot. If you rotate the tires in different directions, you can pivot. We have a small robotic arm coming out the front, a boom on the back for an antenna and a GPS module, and then all of the instrumentation and computers and things like that go on the inside section there. There are 4 tasks we had to do. Something called an extremophile search, instruction panel, astronaut rescue, and the site survey. We'll get to each of those. So Monday, around 7 o'clock, we left Waterloo for Utah. We packed up our rover in a van, and it took up enough space to actually, we removed one of the seats, so we can only take 5 people plus the rover. It's a fairly bulky thing. It has to be less than 50 kilograms, or else you get penalized with some extra some decreases in your points for being overweight. But that said, 50 kilograms is still a lot. You can still make a fairly sizable rover. 3,500 kilometers later, we arrived in Hanksville, and we drove. So that's the equivalent of driving back and forth from Ottawa to Waterloo something like 6 times. It's a pretty good distance. We pushed very hard to get there in a little less than 2 days or so. And everybody else thought that it would be a good idea to bring a van as well. In fact, everybody had the same van. We could recognize ours because we had a nice little roof rack there. We, coming such a distance, we needed the extra space to hold clothes and things like that. Friday, 5 in the morning, we're out. We're ready to test our rover. We set it up. We booted up the camera systems and the communication system, and disaster strikes. We actually had a power board fail just before the competition began, which was quite unfortunate because we were about to actually do some real testing, and unfortunately we weren't able to repair it in time for the first event, but we did get it fixed later on. So this is Pablo here. He's busy in the background working on soldering and debugging one of our circuit boards there to try to fix it. This is the finished rover here, and you can see it's nice and dark outside as we test it. Of course, engineers and scientists like to work at the middle of the night or at any time possible, and always last minute. And unfortunately, it always ends up being last minute.
Sounds familiar, right?
So this is what our lab away from home would look like. We turned one of the, so we were given 3 hotel rooms by mistake, so we took one of the hotel rooms and made it into a small lab. Well, actually, I don't know if you'll be able to, there's a bit of narration, it might be a little low in volume, but I can talk you through it anyway. So it's a spot dark there. Again, Pablo's there working on circuits. The bed is full of junk. There's our rover. Camera system on the top. That's Matty there. And I'm asking Matty, what do you think of the room? And he says it's an engineer's dream. And Michael over there says, it's a little bit messy. He says, exactly. So the this video, the reason I show this video, is that you have to bring as much as you can with you. You never know when something is going to fail or what's going to break. So you have to bring as much as you feasibly can in your vehicle, whether that's a real space mission or a simulation or a competition here. Things can fail for any number of reasons, and I'll talk about some of the lessons we learned at the end, but things like dust and vibration were very detrimental to our performance. So 8 o'clock that same morning, Friday, we were slated to perform the extremophile search. Now, an extremophile is something that grows in extreme environments. So the particular bacteria we were looking for was called lithotropic cyanobacteria. Cyano-blue bacteria is a little life form that grows, and also just desert lichens and things like that. So we were just looking for life in the desert. The day beforehand, we had walked around and actually picked up some rocks and seen it, so we knew it was out there. But finding it with the rover to tell robotically from a distance is actually quite hard. We were operating the rover, the competition provided for up to 1.5 kilometers distance between the base station and the rover, so yeah, at that point you're barely able to see it. You're also not guaranteed line of sight, meaning that the rover could go behind a hill. We have to be able to keep our communications, keep our video feeds, and be able to control and see what's going on. We weren't allowed to watch the rover. So at 8 o'clock, we weren't able to perform our survey, but we could still talk about how we were going to perform it. We had something called a spectrometer on board. The spectrometer reads a patch of ground, looks at the different frequencies of light that come back and reflect back, and they can tell you about the composition of materials. So 1 o'clock comes around. Pablo's been working away on the circuit board at this time, and after a few hours, we thought we might be ready, but we just didn't make it in time for the second event of the day. There are only 2 events in the day, so we figured, good, well, we'll have the night to work on it. Now, the construction panel task was to have your rover drive up to a panel and perform different operations on the board according to a set of instructions that were actually printed there. So you had to look at the instructions and then perform the task. So here's a small video of what the actual instruction panel looked like. So there's the instructions. You would have to read that with your camera remotely. Flip some switches, insert some electrical plugs, and turn some dials. So it's quite a demanding task. From a robotic arm perspective, it means you need several degrees of freedom, and you need a manipulator, whether it's the robotic hand or whatever you choose to use, that's quite flexible. Being able to think about what your arm is doing when you flip a switch, or when you grab a plug and insert it. From a robotic arm perspective, that's quite a challenging thing to do. So we decided we'd take naps. We'd been up most of the night. We took a small nap, and then stayed up the whole next night as well. You'll find competitions like this, you don't really get a lot of sleep. But that's what university is good at training you for. Once again, you stay up late doing things last minute. 7 o'clock in the morning again. The competition was about to begin around 9 that day. And we began to test. This time, we had some success though. So we brought it up to the parking lot of our hotel, gravel road there, and decided to take it for a test spin. And as you can see, it's performing pretty well now, actually. We took the robotic arm off. We didn't need it for the second day, so it was a little bit lighter, a little easier to control. Again, you can see the antenna. That's the GPS unit there. Our main video camera, secondary video camera, our communication system there, and all the electronics inside this bin, and 6 wheels again, so it can pivot to turn. So 9 o'clock rolls around, and we were to perform the astronaut rescue task. Now this task, they were planting a fake astronaut in the desert hills and asking you to find it. You wouldn't be able to see it from where you were, so you couldn't just look around. You had to actually go out and be near enough to an astronaut that you could deliver something. So we strapped the box on top of the rover and started driving around looking for it. They gave us the last known GPS coordinates. The idea is you drive to that coordinate and then you look around trying to find it, and then you search the general vicinity. And you're supposed to deliver it within a meter, and delivery was just being nearby. So for the astronaut rescue, I don't have a video of our result, but I have a video of the actual environment where it took place. So the tent that you saw there was the command station. You go inside the tent so you can't see anything. You set up your communication system outside, and you drive her out. A lot of teams, so they gave the GPS coordinate in a particular format, and a lot of teams had trouble translating things back and forth. So even things that you can easily get ready ahead of time prove to be difficult in the field when you're in a rush situation. So between these two hills there, that's where the astronaut was located, just on the other side of this little hill here. Starting to see the blurry pause at the end there. But we made it about here. So we weren't too far away. We got a certain number of points for being X number of meters away, and we had our first successful event, which was a real boost there. So 2 o'clock, it comes